Hello. Welcome to carbon chemistry classes. Today's topic is chemical kinetics. Integrated rate equations we will see today. For the previous classes, you can watch the previous videos. It's chemical kinetics part 1 and chemical kinetics part 2. Come to the chemical kinetics part 3. So today in this class we will learn integrated rate equations. Integrated rate equations for zero order, first order, second order also. But for the competitive exams, these two are important. So A gives rise to products. Now rate is equal to some constant K into A and power 0, because zero order reaction concentration power 0. Now rate is equal to K, A power 0 is 1. Now rate is minus D, change in concentration by dt is equal to K. So minus dA is equal to K into dt. Integration on both sides. Integration on both sides. We'll get minus D concentration of A is equal to K into dt. Here integration differentiation both are gets cancelled, so minus A is equal to Kt plus Cc is integrated rate constant or integration constant. Here C is integration constant. So for C, if t equal to 0, A become A naught, initial concentration. So substitute. So minus A naught is equal to K into 0. K into T is 0 plus C. So now C is equal to minus A naught. So substitute C in equation, let this equation is 1. Now substitute C in 1. So here minus A is equal to Kt plus, what is C value? C value is minus A naught. So I can write minus of A naught value. So now what I can write is A naught, if you bring this side, so A naught minus A is equal to Kt. Now K is equal to 1 by T A naught minus A. This is what the final equation for first order. This is the final equation for zero order reaction. Characteristics of zero order reaction. Whatever the zero order reaction, it should obey the equation A is equal to A naught minus Kt. Compare this above equation with y equal to mx plus c, where m is the slope and c is y-intercept. So when I am going to compare the above equation with y equal to mx plus c, so y is equal to mx plus c, so it is c, this we can write mx. So instead of m, so what is the m minus k? What is the c here? A naught. And what is the y? Y is A. And what is the x is t. So if you draw the graph for this data, so on y-axis we have concentration of A, on x-axis we have t increasing in these directions. So what is the C? C is A naught. So it is just like y-intercept. The line cuts at y-axis at A0, means initial concentration of A. But M is slope. Slope is a negative slope. So the line slope is, this is slope is minus K. But this value is, what is the C? A naught. Because this line cuts the y axis at point, that is what, y intercept, that is nothing but C A naught. If you see half life of the reaction, half life of zero order reaction, half life of zero order reaction. Here first of all you should know what is half life. Half life is the time required for, the time required for completion of initial concentration to its half. K is equal to 1 by T into A naught minus A. A naught minus A. When T is equal to T of, it become initial concentration by 2. So substitute these two in the above equation. So K is equal to 1 by T of A naught minus A naught by 2. So that is equal to, I can write T of is equal to K, 1 by K into 2 A naught minus A naught by 2 is nothing but A naught by 2. So A naught by 2. So now T of is equal to, so A naught by 2K. This is very important for competitive exams. Now we'll see some examples for zero order reaction. This is a first order reaction. Into the second equation, third example is decomposition of ammonia in presence of molybdenum surface. To NH3 in presence of molybdenum become N2 plus 3H2. Both are gases. Next we will see first order rate equation. First order reaction. So first order reaction, that A gives rise to products. Now rate is equal to K into A power 1. Here let initial concentration is A or A you can take. So concentration after T seconds is A minus X. We can write rate is dx by A minus X is equal to K into A. This is my, we can write dx by dt is equal to K into, after T seconds A become A minus X. So A minus X. So rate is decreases minus dx by dt. Now minus dx by A minus X is equal to K into dt. Integration on both sides. Integration on both sides. So integration minus dx by A minus X is equal to integration T into dt. So now integration 1 by x dx is nothing but ln x. Integration 1 by x dx is equal to ln x. So by using that formula, what we can write, minus ln x means A minus X is equal to k t plus c. The c is integrated constant. Substitute t is equal to 0 and x is equal to 0. We will get constant c. So now ln a minus 0 is equal to 0 plus c. Now c is equal to minus ln a. So substitute c in equation 1. Let this equation is 1. So substitute c in equation 1. So ln a minus x is equal to kt plus c. Instead of plus we can write ln a. Now ln a, if you see this side, ln a minus ln a minus x is equal to kt. Log a minus log b can be written as log a by b. So I can write ln a by a minus x is equal to kt. ln can be written as 2.303 log a by a minus x into is equal to kt. This is what first order rate equation, integrated rate equation. Characteristics of first order rate equation. Whatever the equation, if it is follows first order, it must obey the equation k is equal to 2.303 by t log a by a minus x. Now k is equal to 2.303 by t log initial concentration A naught and concentration after some time is A. Now this can be rearranged. KT by 2.303 is equal to log A by log B, log A minus B, log A minus log concentration of A. So if this is the side, log A is equal to log A naught minus KT by 2.303. Compare this equation with y equal to mx plus c. Y equal to mx plus c. So now y is equal to log A, m is equal to minus k by 2.303 and x is equal to t. And what is the c? C is equal to log A naught. If we draw the graph for this data, so on x-axis we have t is in direction. On y-axis we have log A, and negative slope is there. So it cuts somewhere else on y-axis with negative slope. So here slope is equal to, what is the slope? Minus k by 2.303. And what is this point? Is log initial concentration of A naught. The half-life of first order equation. So first order equation k is equal to 2.303 by t log a by a minus x. So half-life means the time required to consume half of the initial concentration is called half-life. So initial concentration is A. So initial concentration x become A by 2. When t is equal to t of, then x become A by 2. Initial concentration by 2. Now substitute k is equal to 2.303 by t of log a by a minus a by 2. So what happens now? This become 2a minus a by 2, a minus 2. So this can be written as t of is equal to 2.303 by k log a by 2. That is nothing but log 2. Log 2 value is 0.3010. So t of is equal to 2.303 by k log 2 value into 0.3010 is around 0.693 by k. Now we see some relations in first order rate equation. Those are most useful for competitive exams. For example, relation between Tx percentage to T of means 50 percentage. Tx percentage consumed means we can write what 2.303 by k log x percentage is consumed. So 100 is supposed initial concentration, 100 minus x is consumed. Now what is the T of? We have T of is equal to 0.693 by K. That can be written as 0.3 into 2.303 by K. So now if you divide Tx percentage to T of, so I can write T of by Tx percentage is equal to T of is 0.3 into 2.303 by K by 2.303 by K log 100 by 100 minus x. So 2.303k, 2.303k gets cancelled. So T of by Tx percentage is equal to 0.3 by log 100 by 100 minus x. Relation between Tx percentage completed and Ty percentage completed. So now Tx percentage completed in the sense 2.303 by K log 100 is initial concentration, 100 minus x, 100 minus x. Now Ty percentage completed 2.303 by K log 100 by 100 minus y percentage. So take Tx percentage by Ty percentage. So Tx percentage by Ty percentage is equal to 2.303 by K log 100 by 100 minus x by 2.303 by K log 100 by 100 minus y. So both are gets cancelled. So final equation Tx percentage by Ty percentage is equal to log 100 by 100 minus x by log 100 by 100 minus y. Generally, T of is directly proportional to 1 by concentration of initial concentration per n minus 1, or this is equal to initial concentration power 1 minus n. So T of at 1, T of for the reaction 2. So we can write A2 by A1 power n minus 1. This is first one, hydrogenation of C2H4 plus H2 in presence of platinum surface. It is become C2H6, and asteroid process inversion of Keynes over. Next is the second order rate equation. Here the second order can be written in two ways. One is 2a gives rise to products. 2a gives rise to products. Now rate is equal to some constant a into a power 2. And the second case is a plus b gives rise to products. So this is also case we have. Now in this case rate is equal to K into concentration of A and concentration of, we can write rate d by dx by dt minus is equal to K into A minus x whole square. So now dx by a minus x whole square is equal to k into dt. On integration both sides, dx by a minus x whole square into integration k into d. Upon doing all these calculations, we will get, so how can we write means a plus b gives rise to products. So initial concentration at A and B 0. After t seconds, x percentage is consumed from A and the same x percent is consumed from B. So A minus x, B minus x is equal to A. Now the rate minus dx by dt is equal to K into A concentration is A minus x and B concentration is B minus x. So upon doing all the integrated rate equations, so the final equation what we get is, upon doing all the integrated equation, the final equation what we get is minus dx by dt is equal to k into a minus x b minus x is equal to t is equal to 1 by k 2.303 by a minus b log b into a minus x and a into b minus x. Thanks for watching.